pointers. Okay. Yeah. Thanks for recording. I forget to do it myself. All right. And can you see my screen? Yep.
Yes, sir.
Okay. So we stopped here and already renamed this. Yeah, please mute yourself. There's some noise coming. Please mute yourself. Okay, thank you. So someone should tell me what pointers is. Pointers are. Yeah. What are pointers? You have done this in C, right? Yes, anyone, please? What is a pointer? What does the name suggest? I mean, like you're calling this thing a pointer, so what is it? What does it do?
Sir, it points to another object of the same type.
It points to another object of the same type. What do you mean by same type?
So it holds the address of a variable.
Yeah, mute yourself, please. Yeah. No, both of you are correct. So pointing means holding the address of a variable. Okay, that is fine. Yeah. So yeah, and why would we want to do such a thing? Yeah, we already have so many like data types, functions, etc. We can do loops and why suddenly want why do we want a pointer to hold the address of something? What is the utility? Let's think about it for a while. Why would
Sir,
we?
sir,
Yes.
in functions where we want to change the actual value, not the copied value.
Sorry.
In functions where we send the references and not the copy of the variable.
Oh, okay, fine. Okay, yeah. Instead of sending the copy of a variable, we want to send the actual variable. So we in a way we tell the function the address of the variable in the memory, right? Okay, that's okay. Anything else? Yeah, in a way, the pointers are also responsible for accessing array element, but yeah, that's in my opinion not the most important. So, something very important is used. I mean, is obtained by pointers, achieved through pointers. What is that?
So maybe because the actual structure may be very space heavy, but a pointer is only 4 bytes no matter which, so it's like more efficient to pass it in terms of space.
Yeah, we can say that. I mean, like maybe accessing arrays. Yeah, accessing something in an array and passing it to some function. Yeah, that is fine. Something else?
And like making linked lists, so basically linking some structures also.
That does not follow the like conventional like linear storage that we like that is offered by RAM and yeah. So something that is not an array and all that. Yeah, something more complicated than an array. Yeah. So various places in the memory can be linked directly through a pointer, and we can achieve more complex data structures. Okay. So now we try to write down a pointer. Yeah. Yes. So let's just say some normal variable is int a is equal to 45, float p is equal to 23.5, char c is equal to r. And so just let me compile once, and I'll name this as pointer 1. Good enough. And now tell me, how do I define a pointer here? So each of these. So the thing is that there cannot be a general kind of pointer that points to all of these. As someone said a while back, I mean just now, a few minutes back, that pointer should point to the same data type. Like pointer needs to know what it will point. So we are creating pointers for each of these. So star is pointer to something. Yeah. So can we say such a thing like how do we do this then? Let's file once more. Let's see how we can point to something. Can we say that pointer 1 is equal to a? Can we say this? No, we cannot do. So why are we? What is this coming here? Tell me. Why is this error coming?
Because pointer stores the address of a variable and we are storing the value, so it will
Correct.
not pass.
Yes. So this is not the way to do it. I'm not even trying to store the address of a variable, and so this is not allowed. Not allowed. So pointer needs to and so the address of a variable is basically, it is denoted by the ampersand sign followed by the variable name. I can say this. Yeah? Fine. So and followed by variable name denotes the address of the variable. Okay. So yeah, why not see out? Let's see what this means. Yeah. So this is the address, because pointer stores the address of the variable, right? So this is the address, And so what if we do this? Okay, so this is the address. So this seems to be the, okay, so this one is the address of the, so this one is what the pointer stores, and this is the address of the pointer itself then. So how do we get the value at the address of the pointer? Anyone? So can we just let's check. So maybe this. Okay, so this asterisk, it denotes the value stored at the address of the pointer. So since ampersand means, let's play a bit with this. Yeah. How about this? Is this valid even? Let's check. Okay, so ampersand means address. So the address of the variable pointed at by the pointer. I mean, so you can see that this and this are the same, right? No, sorry. Yeah, okay, right. Yes, correct. So this stores the address of the variable, and yeah, you have it there. And what about the opposite? Yeah, so this is basically the value stored at the address of the pointer, which is the same. All right, and so this we have done for an integer data type. We can always do the same with the other two shown here. Yeah. So why is this? Wait a second. Why is this minus? Okay, so this is different from the others. Yeah, I'll have to check this one. So the question is, okay, so yeah, this one, so let me change it to say T, and what does it do? Same thing. Okay, so this T minus, I'll have to, yeah, I'll have to get an explanation for this. Okay, so yeah, this one I'll tell you later why this is like this. I've never noticed it before. Okay, so basically this is how to point at variables using a pointer. And all right, so what else? We can perhaps directly now. Shall we go to how to use an array, or begin with I guess let's start with an implementation of this thing. Okay. So the implementation that, let's delete this. So passing like a variable to, like instead of its copy, passing a variable to a function is what we'll do when we return to functions in more details. But first, let's do a slightly different implementation of a pointer. So the thing is that, yeah, this is also a kind of revision, but yeah, this is important because you can modify this slightly and various beautiful things emerge. So what we can do is, say you are storing something like stored value. Then together with it you define a pointer which points to the next stored value, and again another pointer to the next one, and so on. So you know that at least most of you know and recall that this is a linked list. So we are going to take a look at the code of a linked list. Okay. Yeah, I have not started structures officially yet. So basically, a structure or even a class, we'll go into the differences later. These clump several types of variables together, and it's kind of you can consider it as a derived data type. Sorry, it's very convenient while maintaining records to do such a thing. And also you need to store the pointer somewhere. So we'll define our own thing here. So let this be a, so each unit is called a node, and this is our single node or link of list, and we'll store an integer here. So each node will have all this, and link. So a pointer, it points to some data type, right? So this link is that data type which we are creating now. Okay, next. And yeah, why not do something like more powerful? So this is a doubly linked list. And yeah, so can start with this main here. And see. One second. The new point, I guess, yeah, it's done with the new pointers, no? Main, or shall we write the function? Well, let's. Yeah, this is just the definition of a node. We need to write something here, and so we require functions to do this. So insert or delete nodes. Insert or delete nodes. Yeah, so better. Yeah. Better create a class out of this thing. Check. So we will. So what is this? Yeah, let me include some more here. Okay, and this is our linked list. So the first link, it has the first link and this last link have some names, right? What is the first link usually called?
Yes.
First link is called the head, and the last link is the tail. Right. So say that okay, just let's first we'll define the alright, and then what to do? We will. Okay, let's first try to write the the addition. I mean the function that will add an element. Say, if it adds an element, I mean it will not return anything. Yeah. So let us say void and item, and it should be passed. So this is the value basically. This is the non-pointer value that we link this to. So it should be passed integer d. Yeah. how should we proceed writing this? So we can add on both sides, no? So let's just be adding a new node in front the list, and yeah. So this means that it is function already defined in the class. And we can this is our pointer of the type link, is the name of the pointer, and we use new operation to create such a pointer. Okay. And now that so it's so this link on node is the thing that we have created, and we can say that basically okay, we need to create such a single node first. Say new link data means the data of this new link, we'll say it is D. So basically, variable gets the integer value supplied to the function, and yeah, so this is yeah, this is for adding a new node in front of the list, and so that means it should look like this, no? So save. So something like, suppose we have 5 pointed to it. 2. These are the values that suppose are held by the linked list already. 7. And what this does is it creates D, and then it does this. So we can safely say, okay, so the actually, sorry, what have I been doing? This is wrong. It should be like this, no? Because doubly linked list, and maybe I will just put a bracket here. That is maybe this. Yeah, this is what it is. So, but every node has pointers on both sides, right? So this also has a pointers to the left. So we'll write that point. I mean, it points to nothing. It's the null pointer. Yeah. So it points to null. We'll say. So new link, like previous. So there are 2 pointers here, right? Previous and next. This is equal to null. And we have assumed that the first pointer is called head, and so new link is next is head. And if so, like some exception handling we have to do. What exception can there be for this? Like if head itself is null, right? If head itself. Sorry. No. This is not. I'll not do exception then. Okay, so sorry. Forget what I said. So the thing that we have done is we have just joined this one, and we have done only this. Okay, but this guy has to point to this, right? Yeah. So let's say if the head is already there, and this has to be the D here. I mean the node containing D. It has to be relabeled as the head, because we are considering. I mean, like after we are done invoking this once, again the last node should be the tail and the first node should be the head. But here we are, adding one node in the beginning, so that node should become the head. Okay. So head points back to the newly old head. Yeah. And then new node becomes the new head. So this is they will define this one. We haven't defined this yet. No? So we can do this private, specially name this and this is all right. And so what else is there? So we need like, okay, so if this was yeah, I think now this we'll have to deal with the case where so if previously the head and tail were the same node, then we should separate them out, and we'll say that if new link next is not equal to null, and new link equal to null. So this is first instance, the head and tail. Separate out. Is a tail is equal to new link next. Okay, so this is how we add something to the beginning of the linked list, doubly linked list, and let's think about how we'll. Let's look at this for a moment or two, and we'll think about how to do the same. It's similar, how to do the same to the end, the linked list. Yeah. So basically it should look similar. So let me just copy paste and then we'll see. All right. Okay. This is the same, and that will be the same, and this should be the tail. Yes. And this should be null. Okay. And if head, let's assume that is not equal to null, then yeah, we better say that. Okay, so this is just everything is similar, but we are just replacing head with tail and previous with next and vice versa. Tail, it's really the same. Okay, and okay, the first instance with the head and tail separated out. And can anyone tell me what this will be, this part?
Next will become previous.
Yes. And so this will be again previous. And so tail, link, this should be head, no? Okay. Okay. What else can we do? Okay. So similar, we'll write just similar things. So these were both insertion functions, yeah. And we want to delete the top. Now let's. So delete first and delete last. This kind of thing, yeah. So I'll like. Oh, I've not defined anything here. Okay, so let me save. And this does not need any argument, right? Because yeah, so it won't, yeah, it will just delete the first node, whatever it is. Yeah, okay. So head can be null, right? In which case this is not going to do anything. So just one node is there. And so if only one node is there, then what will it do? This one is trivial, and so what should it do now? So it will just turn that into the pointer. Or else head is equal to head next. So basically the second node becomes the new head, and first node. And this is and so analogously, if I yeah, someone should dictate, please. Yeah. Tell me the function whole, but what should it be? This constraint will be someone else, please, not the people who have already answered.
Tail is equal to.
Okay. Actually, this can remain. I mean, this can remain the same,
Yes.
but because it's the same thing. Calling. I mean, if the head is null, tail is also null. But yeah, it looks better. So now. And this one is what?
Tail previous is equal to null.
And this one?
Tail is equal to tail previous.
And the explanation should be what is happening?
Last second node becomes the new tail.
Yes. And here, yes. Right. So right, and yeah, so we have seen first 4 functions on W linked list, and we'll add a few things and maybe go for maybe like make the code a little bit easier on Saturday. Yeah, so this is the logical time to stop. Saturday will be a like slightly long class at 2 o'clock, and yeah, so we'll complete this linked list and also see other applications of pointers, and maybe we'll start officially with classes. Alright, so yeah, I'll see you on Saturday then. And remember, you have till Tuesday to submit the lab work if you have not submitted it, like the complete lab work. All right.
Sir,
So
including the Sunday practice lab.
no, practice lab was just for practicing. Yeah.
The one on last Wednesday.
Yes, yes, yes.
Okay.
Of course, what we did on Sunday, you can do for practicing, but it will not be evaluated. Okay. So yeah, better stop the record and